Hello students, hope all of you are doing well. So today I welcome all of you in my next session where we are going to discuss about the area by using the double integral. So this is one of the most important application of the double integral while finding the area of a region. Whenever we are in class 12, already we have learned how to find out area by using the single integral. So here we will just continue our journey to find out the area using the double integral. So before we start the discussion and come to the problem solution, we have to derive or try to understand how the area formulation will come in the Cartesian coordinate system as well as in the polar coordinate system. So first, for our basic understanding, we are considering the Cartesian coordinate system and finding the area from there. Say we are having one region R which is in the xy plane. So how to calculate the area of this region in Cartesian coordinate system? We have to make the grid points, many grids here. That is, the whole region is divided into some small rectangles where some parallel lines will be taken parallel to x-axis and some parallel lines are taken parallel to the y-axis. So this will create the grid structure. So if we just look at this particular portion which I have colored by yellow color, so this portion is considered as a small rectangular portion, small rectangle, which is having the length as delta x and having the breadth as delta y. So everyone know that the area of a rectangle having length and breadth can be easily obtained by just multiplying delta x into delta y. So area of this small rectangle can be find out delta x into delta y. So how to get the area of this whole region? If we take the limit sum, that is limit delta x tends to 0, delta y tends to 0, double integration, it should be double summation, double integration of del x into del y. That is y also becoming very small, this delta y, and delta x also becoming very small. Then whole this region will be created over this double summation. So this double summation will be converted to double integral as delta x and delta y tends to 0 under the limiting case. So we get the formula for area in the Cartesian coordinate system, that is double integration over r dx into dy. Now let us come to understand the area in the polar coordinate. In the polar coordinate we are having little difficulty. Here only we are having one line that is known as the initial line, and with respect to some origin the distance should be measured. This distance is known as the r, and the angle of the line that will create, that is known as the theta. So here we are having a region A, which area we have to find out. Here also what we have done, we have drawn some lines starting from O that will cover the whole A region by the green lines, and also we have to make some arcs, so that this small rectangular shape of things we can be able to obtain as we have done in the Cartesian coordinate system. Say we are having some 4 points here, we have created one small rectangle, so which is having the Cartesian which is having the coordinates as points as P, Q, R and S. Since we are measuring r from O and having the angle from this to P, for P is theta, so P is having the coordinate as r comma theta. So the next point is the Q point. So for Q point we have traveled a little bit far distance, but which is along the P only. So this is nothing but our delta r. Now we have gone to little bit upside, right side of P, so to get S through a arc. So for this we have traveled delta theta distance. Okay, so S is having the coordinate as r comma theta plus del theta, and r is along S, so this will be r plus delta r, because little bit more distance we have gone through s there, and the theta is making same. So coordinate of r is r plus delta r, theta plus del theta. Now we know from our class 11-12 concept that how to find out the arc length. So the arc length ps, that can be easily find out by r into del theta. Actually the arc length formula is r into theta, but here the angle between p and s is del theta, so we are having the arc length as r into del theta, and pq is nothing but delta r. So what will be the rectangle or rectangular shape of region area? That is equal to r into del theta into del r. So similarly as before, we have to find out the area by the limit sum definition. So limit delta r tends to 0, del theta tends to 0, double integral of r into del theta del r. So this will give us the area of the whole region. So area can be find out in the polar coordinate system, that is r into dr d theta, double integration over a. So in Cartesian coordinate system, we are having the area formula as double integration dx into dy, whereas in the polar coordinate system, we will have the formula as r into dr d theta. This is the only change. Otherwise, rest of the things are going to be as it is. Now let us come to discuss some solution of some problem. So first we will start with the easy cases, that is the Cartesian coordinate system. So here we are going to find out the area of an ellipse x square by a square plus y square by b square equals to 1 using the double integration. So here I have drawn the ellipse where a is the major axis length and b is the minor axis length. Now definitely this area or this region is not a shape of a rectangle. So one of the limit is going to be variable, other limit will going to be constant. So for making x as a constant, I am considering this length only, that is 0 to a. And for y, all we know now that we measure y vertically, so we have to shade this only one portion in the one quadrant, first quadrant, by some vertical lines. Because the ellipse is symmetric in nature, so in 4 quadrants the areas will be same. So we will find out the area in one quadrant and then we multiply with 4, so that the full area we will get. So y will start from x-axis, so y value at x-axis is going to be 0 and y will go up to the ellipse. So on the ellipse the value of y is, that is b into root over of 1 minus x square upon a square. So y will range from 0 to b into root over of 1 minus x square by a square. So 4 times x equal to 0 to a, y equal to 0 to b into root over of 1 minus x square by a square dy dx. Since y limit is variable, we have to perform integration with respect to y first. So integration of dy is y, that is very easy to understand. Now we have substituted the y value. So after substituting, it is coming b into root over of 1 minus x square upon a square dx. I have taken the LCM and a square root over is a is going outside. So 4b by a is constant, it is going out of the integration, and we are having 0 to a root over of a square minus x square dx. Now this formula all of you know, this is x by 2 root over of x a square plus minus x square plus a square by 2 sine inverse of x upon a. Limit is 0 to a. Whenever we substitute this, the first part will become 0. If I put x equal to 0, it will vanish, x equal to a also it will vanish. So only we will get the value from the second part, that is a square by 2 into sine inverse of 1. Sine inverse of 1 is pi by 2. So we get the result of the ellipse as area of an ellipse equals to pi into a into b. Next, let us come to another problem, problem number 2. So here the question is, find the area by double integration where the area is bounded by one circle x square plus y square equals to 9 and a straight line x plus y equals to 3. So let us first draw the region and try to identify the limits of the variables. So here x square plus y square equal to 9. It is a circle centered at a point 0 and having the radius 3. So this is the point 3 comma 0 and this is another point 0 comma 3. X plus y equals to 3, that is another straight line like this. So we need to calculate the area between these two lines. So if we can see that this is the region for which we have to calculate the area. So definitely this region is not in the shape of a rectangle. So one limit must be variable, another limit is constant. For sake of simplicity, we have considered x limit as constant. So x will vary from 0 to the radius maximum. So that is the range of x. So x will be from 0 to 3. But how we will measure y? We measure y vertical. So y will start from this straight line and y maximum go up to this circumference of the circle. So on the straight line, what is the value of y? The value of y is 3 minus x. So y will start from 3 minus x and y will go up to the circumference of the circle. So x square plus y square equals to 9. So from there y value is root over of 9 minus x square. So 3 minus x2 root over of 9 minus x square, that is going to be the range of y. So since y is a variable limit, we have taken the integration of y with respect to y as first. So y equals to 3 minus x to this root over of 9 minus x square dy. Integration of dy is y only. We have substituted the upper limit minus lower limit. So we are having this result. Thereafter we are having two different functions in the integration, right? First function is root over of 9 minus x square. So it follows the structure of root over of a square minus x square. So we have used the formula for this. And for this part 3 minus x, it is very simple to integrate, that is 3x minus x square by 2. Limit is 0 to 3. After substituting the limit, the final result is going to be 9 by 2 pi by 2 minus 1. It is very easy calculation. Everyone can do that and verify. Now we are going to discuss some of the area formula or area calculation in the polar coordinate system. So commonly we are having this type of problem. So I have discussed these problems here. Let us find out the area that lies outside the circle r equal to a cos theta and inside the circle r equal to 2a cos theta. We are familiar with the circle in the Cartesian coordinate system, but not familiar with the polar coordinate system structure. So let us try to understand how to draw the circle r equals to a cos theta in the polar coordinate system. We know that in polar coordinate system, the relation between the Cartesian xy with r theta is x equal to r cos theta, y equal to r sin theta, where x square plus y square is going to be r square. Now if we put r equal to a cos theta, so what is the value of r? R equals to root over of x square plus y square equals to a into cos theta. What is the value of cos theta? Cos theta equals to x upon r, and r equal to root over of x square plus y square. So we get root over of x square plus y square equals to a into x upon root over of x square plus y square. So we have just cross multiplied it. We get x square plus y square equals to ax. We take ax in the left hand side and make a whole square or perfect square formula. For that sake, I have added a by 2 whole square on the left hand side and adjusted it by taking a by 2 whole square on the right hand side. So on the left hand side, we are having the equation like x minus a by 2 whole square plus y square equal to a by 2 whole square. Now it is looking similar or familiar with our Cartesian coordinate circle structure. So what is the center of this circle? The center of the circle is a by 2 comma 0, because y minus 0 is there. And what is the radius of the circle? That is a by 2. So r equal to a cos theta, it represents a circle which is centered at the point a by 2 comma 0 and having the radius a by 2. Similarly, r equal to 2a cos theta, it also represents a same circle, but center will be changed. It will be centered at a comma 0 because the 2a is there, so it is getting double and radius is becoming a. So now we have to draw the circle. So here you can see that this is the circle a by 2 which I have drawn by the green color, a by 2 comma 0, r equal to a cos theta, and r equal to 2a cos theta, that is the red color circle. So inside this 2 we are having the region that is shaded by the yellow color. So now what is the variation of r? We can see r varies from a cos theta, that is from the inner circle to the outer circle. So r will vary from a cos theta to 2a cos theta. And what will be the variation of theta? So theta is coming from the negative side, that is from here. So you can say from minus pi by 2 to the plus pi by 2, the full variation from here to here. So since this region is symmetrical, so we can just calculate in the first quadrant and make it double. Therefore we can get the angle as 2 into theta 0 to pi by 2, r equals to a cos theta to 2a cos theta, r dr d theta. That is the formula for the polar coordinate system. So simply we have done the integration now. So what is the value of the integration is coming? R square by 2. Here we have substituted the upper limit and lower limit. After calculating, we getting 3a square, which is constant. We are taking it outside. So inside we are having cos square theta. To integrate cos square theta, we have to make it into the cos 2 theta structure, that is the double angle structure. So to adjust it, I have divided by 2 multiplied with 2 inside. Now 2 cos square theta formula is 1 plus cos 2 theta. After taking 1 plus cos 2 theta, we can simply integrate it and the result is coming theta plus sin 2 theta upon 2. Limit is 0 to pi by 2. Whenever we substitute, the result is coming 3 by 4 pi a square. It is very, very important for your exam. Instead of, sometime we can see that r equal to a cos theta, sometime in the question it can be given as r equal to a sin theta. So what will be the structure for that? It will be as it is same, but only the position of the center is going to change. The center is going to be 0 comma a by 2. Now the center will lie on the y-axis if r equal to a sin theta is given. Now let us try to understand with a small example. So suppose the same problem, previous question is given, find out the area between r equal to 2 sin theta and r equal to 4 sin theta. How we can get that? So here the solution will be like this. So this will be the circle that is equal to r equal to 2 sin theta. Center will be on the y-axis having the coordinate 0 comma a by 2. Another circle will be there that is passing through origin definitely, and this will be the circle r equal to 4 sin theta, which is having the center here, that is a. So here a equal to 2 here, so it will be having the coordinate like that. So what is the center of this circle? 0 comma 1 and radius is 1. Similarly for this circle, center is going to be 0 comma 2, radius equal to 2, radius is going to be 2. Now let us come to the solution. Therefore what will be the solution? Same answer it will be. This region we have to calculate, same region. So answer is going to be 3 by 4 pi a square. If we use the same formula, so here a equal to 2, so 3 by 4 pi into 4, so answer is going to come as 3 pi. So by this way also you can be able to calculate. This is the last question for today's lecture. We have to find the region between lying inside the circle r equal to a sin theta and outside the cardioid r equal to a into 1 minus cos theta. So this is the heart shape of structure which is known as the cardioid. So here from cardioid is inside and outer region is the circle. So this green color line is a shaded region is the required region which we have to evaluate. Area of which we have to evaluate. So area formula is r into dr d theta. So if we make a line, that is it will measure the r. So r will start from this cardioid and it will go up to the circle. So r equal to a into 1 minus cos theta to a sin theta. Simple integration we have done and we have substituted the upper limit minus lower limit. So we get a square sin square theta minus a square 1 minus cos theta whole square. So we have just simplified it. After simplification we get cos a square by 2 as outside, cos 2 theta 1 minus 1 plus 2 into cos theta. How we get this cos 2 theta? From this sin square theta minus cos square theta we get cos 2 theta, and rest of the terms we keep it as it is. Now simple integration we have done. Cos 2 theta integration is sin 2 theta by 2 minus 1 is theta, and 2 cos theta integration is sin theta. So after substituting all this value we get the answer as a square 1 minus pi by 4. So with this today's lecture we are going to close. Next lecture